Hi, I'm Natalie Rhodes, and this is Into Math's 5th grade, Module 20, Lesson 2. I'm going to start off by going over the I Can objective, which is just I can classify triangles. The learning objective is to classify and draw triangles using their attributes. Prior learning is that students classified two-dimensional figures using angle measures and the presence or absence of parallel or perpendicular segments. Students identified right angles, and students identified and recognized the relationships between categories of figures, especially quadrilaterals. All right, so moving into the lesson, we're on page 501. We have a Spark Your Learning. It says the house shown is called an A-frame. Architects use triangle shapes in many buildings and designs. So we are given a bunch of triangles, and it says group the triangles according to their attributes. So it's showing both their angles and their sides. So what we're going to do is we're going to make 3 columns showing the differences with their angles and their sides. So what I'm going to do is I'm just going to split up my whole chart into 3. The first one is going to be that there's no equal sides or angles. So no equal sides / angles. Then the next one is if there's going to be 2 that match. So 2 equal sides / angles. All right, and the next one is if all 3 of them match. So all 3 equal sides / angles. All right, and then we're just going to go one triangle by one. And if you look, like the red one has an A in the middle, so then we're just going to write the letter. Okay, so let's go ahead and look at that red triangle. We have the sides that say 10, 11, and 9, and then the angles say 50, 71, and 59. So do we see anything that matches? No, which means there aren't any equal sides or angles, so we're going to put the letter A under here. Now let's go over to the purple one. We have, for the sides, 8 inches, 8 inches, and 3 inches. So we have 2 matching. Then for the angles, we have a 22 and then a 79 and a 79, and again, 2 angles that match. So 2 equal sides and angles, so we're going to put B in that second column. Then in C, if you look at the sides, it has 10, 10, and 10, and then the angle is 60, 60, and 60. So all 3 of them match, so then we would put C in the last column. All right, so then for the blue one marked D, we have 24, 10, 26, and then angles are 30. That little blue square is worth 90. That's a right angle, and then 60. So nothing matches, so we're going to put D in here. For E, we have 7, a 7, and a 10, so 2 of them of the sides match, and then we have a 45, a 45, so 2 angles match, and again, that blue square, which equals 90, which is a right angle. So 2 of them match for E. Then for the light blue one, we have 9, 11, and 19, so no sides, and then the angles are 20, 16, 144, again, so nothing is matching, so we're putting it in that first column. Then last one, the yellow one marked G, we have 11 and 11 and 20, so again, 2 that match, and then 25, 25, so 2 angles, and then a 130. So that G is going to go in that second column. So here is how we would separate out or categorize our triangles based on their attributes of their sides and their angles. All right, let's go ahead and flip the page. We have a build your understanding. Number 1 says the angles of the roofs on buildings can form many different types of triangles. Complete the tables by classifying the triangles by angle measures and by side lengths. So write acute, and this is greater than 0, but less than 90. So acute is 0 to 90. The word obtuse is 91 to 180. And then a right angle is right at 90. So the only thing that could be marked a right angle is if it has that little blue square and it's exactly 90. All right, and then for this, we do need the vocab over to the right with the yellow square. So it says an equilateral equilateral triangle is 3 congruent sides, and congruent means equal. So an equilateral is equal sides, all 3. An isosceles has 2 of the same side, so that's isosceles. And then if it doesn't have any of the equal sides, it's called a scalene triangle. All right, so we are going to just write what each one is. So go ahead and look at each triangle one at a time and then find out, okay, what are the angles? So I'll just do the first one for each and then I'll let you finish the graph. For the light blue one, the angle measurements, all of my measurements are below 90. So I have a 50, a 59, and a 71. That means they're all acute. And then my measurements are 9, 11, and 10, which means none of my sides are equal, which means it is a scalene. All right, and then if it has one right angle, that means it's a right triangle. And if it has one measurement that's bigger than 90, that means it's obtuse. It does not all of them have to be above 90. It's just one. If there's one, that automatically means it would be a right triangle, or that means it automatically would be an obtuse triangle. All right, and then you're going to finish those graphs. Then for A, it says, what do the angles of the right triangles and the obtuse triangles have in common? And then for B, is it possible to draw a triangle that is both obtuse and an equilateral? So if it has an obtuse, that means it's bigger than 90 degrees, and can all 3 of the sides be equal if that angle is bigger than 91 degrees? And then explain. All right, so go ahead and try your best on this lesson and then come back and we will solve it together. So go ahead and hit pause here. All right, let's go ahead and finish in these graphs. So the first one had all acute angles and the side lengths were scalene. Then the next one, it has that blue triangle in the corner, which means it automatically is a right triangle. Then for the sides, 2 of them are the same, and I know that if 2 of them are the same, that's the isosceles. Then for this next one, all of the angles are below 90, so that's going to be an acute triangle again. But all 3 sides are the same, and that means that that's an equilateral. Then, again, there's that blue triangle. So remember, if I have that one of the blue triangles, that means it's automatically a right angled triangle. And then the sides are 10, 26, and 24, so none of them match. So that means it's a scalene again. Okay, and continuing to the bottom one, we have 3 more. So for the measurements, I have 79, 79, 22, all lower than 90, which means it's going to be acute. Then the side lengths are 8, 8, and 3, so 2 of them match, which means that falls under the isosceles. All right, for the red one, the angles are 20, 16, and 144. Whoa, 144. Okay, that's way bigger than 90, which means that automatically, just from that one angle, means it's an obtuse triangle. All right, and the lengths are 9, 19, and 11, which means none of them match, so it is a scalene. And then we have a 25, 25, and 130. That 130, bigger than 90, automatically, again, makes it obtuse. And then the lengths is 11, 11, and a 20. So those 2 11s match, which means it's an isosceles again. All right, then for A, it says, what do the angles of the right triangles and the obtuse triangles have in common? So the right angle is 90 and the obtuse is bigger than 90. So what do they have in common? Well, if we go look at the ones with the right triangles and the 2 bottom, the red and the green, because those are 90 and bigger than 90, that means the other 2 angles have to be acute. So what they have in common is 2 other angles have to be less than 90. All right, and then for B, is it possible to draw a triangle that is both obtuse and equilateral? Well, we only had one equilateral triangle. It was the first green one with all the sides are the same. So if you notice, if all the sides are the same, that means all the angles have to be the same. In a triangle, if you add all the angles together, it's going to equal 180. I don't know if you noticed that pattern, but if you go to any triangle and you add all three numbers, they're going to equal 180. So the only way for us to have an equilateral triangle is for those angles to be 60, 60, and 60. So it can never be obtuse and equilateral because obtuse means more than 90, but the angles are only ever going to be 60. That's as big as it can get. So is it possible? No, it's not possible because the angles have to be 60 degrees. All right, that is it for this lesson. Go ahead and finish up the rest of your problems, and I'll see you back for Module 20, Lesson 3.